Hi, Science 8. So what we'll do today is we'll go over the answers to the last worksheet, which looks at pressure applications. So remember, we talked about pressure as being equal to force divided by area. So first one, number 1 and 2. So it doesn't matter if you're talking about which fluid. Remember, fluids can be liquids or gases. So water or air as examples here. The same thing is true for both. At the higher levels, you're lower in pressure, and as you get deeper with increase in depth, then the pressure becomes higher. So the reason this is if you think about, like, say a swimming pool, what happens is at the bottom, when you get close to the bottom of the pool, what you have is the weight of all the water above you, and that's creating a force on the area of the pool. So that is what pressure is, right? So that's why it hurts your ears more in the deep end, because your ears are sensitive to pressure. So pressure increases with depth. Sea level or atmospheric pressure, we call that 1 atmosphere. And then every 10 meters increase in depth, the pressure level goes up by 1 atmosphere. So remember, we talked about force divided by area, so newtons per meter squared. That's equal to the Pascal. So that's 1 unit of pressure. And then atmosphere is another unit of pressure. Now, when you have fluids, there's two things that oppose one another. There's the upward force of the fluid. That's called the buoyant force, and then there's the downward, which is called the force of gravity. So depending on which one's greater, that'll give you an idea of which way the motion is going to be. So for example, if the buoyant force is greater than the force of gravity, an object is going to rise. If it's the other way around, the object's going to sink, and if the two are equal, like in the last one, then they're going to float. Okay, next one here. So this is basically just like what I just finished talking about. So if you in physics, the arrows represent the direction an object is going, and the length of the arrow represents the magnitude. So here you see the two arrows are equivalent but going in opposite directions. So this one here would be an example of floating. Okay, here your force of gravity is bigger than the buoyant force, so this one would be sinking. Okay, here's the force of gravity is bigger than the buoyant force, so this would also be sinking. One of the ways you can alter the amount of weight in, say, a submarine is by how much water you bring in or release. And here the buoyant force is greater, so this would be rising. Here the hot air balloon. So hot air, so you've probably heard that expression, hot air rises. And so what you have beneath the balloon is you've got a heat provider, and basically you can control that, turn it on, off, or turn it up to higher power. And so what happens is that causes the balloon to rise. Okay, and so here it's going to rise. The buoyant force is bigger. And then here the two are the same, so it's going to be floating. So you're not floating like on water, but you can think of when we say floating, what you're doing is you're keeping the same, in this case, the same altitude. Okay, so now let's start talking about some technical applications. So again, a fluid is either a liquid or a gas, and a fluid system is some type of system that utilizes either a liquid or gas to perform tasks. Okay, so when we talk about machines, a whole point of a machine is to perform a task for you, right? Whether it be a simple machine or a more complex machine. So when we talk about the movement of water, mostly it's water when we talk about liquids, we're talking about hydraulics. And a system that accommodates that is called a hydraulic system. So an example of a hydraulic system would be like in a car garage. car shop when you're getting your car worked on. Say you're getting the tires changed, or you're looking underneath the bottom of the car. In the garage, the there's a lift that basically gets the car to be lifted up, a hoist, and what that takes a lot of force, and what you're using there is a hydraulic system. Okay, and so a hydraulic system, you're building up pressure through pumps. Okay, so just like a pump like you would use to bring water from below ground to above ground, and then you're controlling sort of an on-off switch through what we call valves. Okay, so like when you talk about say your sink faucet, and you want to turn it on, you basically when you're turning, say if it's a twist one, that what you're doing is you're opening up a valve which is going to allow the water to flow out. When you close it, you're closing the valve and the water stops flowing out. Okay, and so the reason why we have to, why it's essential to put the water under pressure is that's the only way you're going to be able to overcome the force of gravity if you're trying to go up, right? And so we do get our water from pipes below ground. So when you think about getting water in your home, it's coming from below ground. You're going to need pumps to do that. Okay, so again, a liquid is under pressure in a hydraulic system. And so like I talked about with that example of lifting up cars, that's called hydraulic multiplication. So what this basically means is whatever force you're putting in, you're getting a much greater force on the other side. So the output force is much bigger than the input force. And the output force is what's causing the cars to lift up in the first place. Okay, a second type of system is a what we call a pneumatic system, or pneumatics. This works off of air, so gas. So think about something like a vacuum cleaner. That would be an example of a pneumatic system. Okay, so it's where you have a pressure differential. So remember diffusion. You're going from high pressure to low pressure. That's causing air to move. And then as the air is moving, it's bringing all the dust and debris, and that's being collected by a filter. That's essentially what a vacuum cleaner is. If you think about tools, a lot of power tools use what's called a compressor. And so a compressor, like in an example of a nail gun, is where you don't have to use a hammer. You basically use a nail gun that's connected to a compressor, and that generates a lot of force that is able to push the nails into wood. Okay, so the true and false here. So hydraulics is a study of pressure in liquids. So that was false. 2 is false. We're talking about a pneumatic system when we talk about gas. 3 is true. 4 is false. That should be a pneumatic system, a compressor. 5 is false. Pumps work through hydraulic systems. 6 is true. And 7 is false. That's a hydraulic system. Okay, so what I'm going to get you to look at for Monday, and I want you to have done for Wednesday, is to now, we're talked about technical ways you can use pressure. Now I want you to look at the biological ways you can use pressure. And there's 2 systems in particular which resemble what's going on here. The example of a hydraulic system would be your circulatory system, which is the blood. So think about the heart is the pump, and then the arteries and veins, those are like the piping, and then the liquid is the blood that's flowing through there. Okay, so I want you to look at that one. And then the second one is an example of a pneumatic system, which would be your respiratory system. Okay, so here's a sealed chest cavity that contains your lungs, and you're bringing air in and out as you inhale and exhale, and that respiration is occurring through a pressure differential in terms of what's outside your body compared to what's inside your body. Okay, so I'd like you to have a look at that and complete that worksheet by Wednesday's class. Okay, so I'm really liking what I'm seeing. Most of you are getting the assignments completed, and then you're submitting them. So keep up the good work. Those of you who haven't, if you're having any difficulty with anything with the questions, just please ask. Some of you have been asking a lot, and so that's great. Just keep it up. Okay, so let's again ask questions and try your best. Don't worry if you can't get every answer. Okay, so I'll stop here. Again, look after yourself, stay safe, and I'll talk to you again on Wednesday. Okay, bye now.